Hi everyone, welcome to this tutorial on angles made with a vector and positive axes. Before we start this lesson, it will be centered around 3D vectors. And 3D vectors can be used to describe position and displacement relative to the x, y, and z axes. Now the coordinates of a point in 3 dimensions are written as a bracket x, y, and z. So very similar to coordinates in a 2D axis. Now vector notation for 3D vectors is very similar to 2D vector notation. Remember, for 2D vector notation we've used an I and j component, but for 3D vectors we use an I, j, and k component. Remember, we can write it in column form as well. Now it's very important that we're able to work out the distance between 2 points on a 3D axis. And it's very similar to how you've worked out the distance between 2 points on a 2D axis. So you can see the similarity. With a 2D axis, it was the difference in the x coordinate squared, add the difference in the y coordinate squared, and square root them all. Now for 3D axes, it's the difference in the x coordinate squared, add the difference in the y coordinate squared, add the difference in the z coordinate squared, and then square root them all. So very similar. Before I start, I just want to review some work you may have done at GCSE, which will help you calculate the angle between the x, y, or z axes and a vector. So let's have a look at a pretty straightforward GCSE 3D trig question. Here we have a cuboid and has the vertices O, B, C, D, E, F, G, and H. And we're given the coordinate H to be 2, 3, 1, and we're given the coordinate D to be 2, 0, 0. And we're asked to work out the angle made between the line OD and the line OH. Well, hopefully you can spot we have a 3-dimensional right-angled triangle. So to work out the angle made between OD and OH, we're going to use trigonometry. All I've done here is just pull out our 3-dimensional right-angled triangle just so it's easier to see. Now for us to use trigonometry, let's work out some lengths. So we need to work out the length OD. Remember the formula. The formula states to work out the length or the distance between 2 points. It's the difference between the x coordinate squared, add the difference between the y coordinate squared, add the difference between the z coordinate squared, all square rooted. So, given this is the origin, it's simply 0 subtract 2 all squared, add 0 subtract 0 all squared, add 0 subtract 0 all squared, and then we're going to square root the whole thing. This gives me the length OD to be 2 units. Now I'm going to calculate OH using the same principle. So I know we have the origin with the coordinates 0, 0, 0, and I have H with the coordinates 2, 3, and 1. Substituting into our formula, I'm able to work out the distance OH. So it's the square root of 0 minus the 2 all squared, add 0 minus the 3 all squared, add 0 minus the 1 all squared. This gives us an answer of OH to be the square root of 14. Now I know what OD is, and I know what OH is, I'm able to use cosine to work out the angle made between OD and OH. Remember, it's the adjacent over the hypotenuse. Substituting in our OD, it's 2, and our OH is root 14. This means cos theta is 2 over root 14, and working out theta, I simply do cos to the minus 1, 2 over root 14, which gives me a final answer of theta to be 57.7 degrees to 3 significant figures. So let's see how this GCSE trig question helps us with 3D vectors. Well, if we use the same knowledge and apply it to the x, y, and z axes, you might see there is actually no difference. To work out the angle made between the vector OH and the x-axis, we're still going to be using cosine. And looking at the x-axis, this means we'll be looking at the magnitude of OD over the magnitude of OH, which is our vector. Applying it, we still have the same calculation and we still have the same angle, which is 57.7 degrees. So it's the same concept, we're simply applying it to an x, y and z axes. Now I'm going to remove those coordinates and write in a general vector A, with x, y and z being our components for I, j and k. So you can see, to work out the angle between a vector and the x-axis, it's simply the x or I component over the magnitude of the vector. And this applies even when we're looking at a different axis. So let's have a look at the y-axis. If the question wanted us to work out the angle between the vector and the y-axis, we're still using cos, because we have our adjacent and we have our hypotenuse. Given the fact the adjacent is the y or the j component, and the hypotenuse is the magnitude of the vector, that means, using cos, the trig ratio would be y over the magnitude of our vector. Now let's have a look at the z-axis. Well, if the question wanted us to work out the angle between the z-axis and the vector, we still have our right angle triangle, we still have our adjacent, and we still have our hypotenuse. So the adjacent is the z or the k component, and the hypotenuse is the magnitude of our vector. So if you're asked to work out the angle between an x, y or z axes, it's simply these formulas that we're applying. So let's apply this to an exam style question. You may have noticed I've used position vectors for all of these examples. And I just want to show you how using the I, j and k directions gives you exactly the same formulas. This is because the x-axis is parallel to that I direction. So the angle made between the I direction and the vector will be exactly the same as the angle made between the x-axis and the vector. This is because the I direction is parallel to the x-axis. And this is the same as the y-axis. If you were working out the angle between the vector and the y-axis, you can work out the angle between the vector and the j component. This is because they'll be the same as the j direction is parallel to the y-axis. And it's the same with the k. So if you were asked to work out the angle between the vector and the z-axis, you'd simply look at the angle between the vector and the k component, because the k direction is parallel to the z-axis, so the angle will be the same. Here the question wants us to work out the angle made between the vector A, given as 2i plus 5j minus 4k, with the positive x, y and z axes. And we're asked to write our answer to 3 significant figures. See if you can give it a go and press pause if you need. Well done. So let's give this a go. Well, first of all, if you know it's the angle made between the x-axis and the vector, we're going to be using this formula. So let's work out the magnitude of A first, simply by square rooting our 2 squared, add our 5 squared, add our minus 4 all squared, thus giving us the magnitude of A to be root 45. Simplified gives us the magnitude of A to be 3 root 5. Now we know the magnitude of A. What does it mean by x? Well, it means the I component, which you can see here is 2. So that means our trig ratio to work out the angle made between the vector and the x-axis is 2 over 3 root 5. To work out what theta is, we simply cos to the minus 1 of our 2 over 3 root 5, giving me a final answer of 72.7 degrees to 3 significant figures. So now we have the angle made between the vector A and the x-axis to be 72.7 degrees. Well done if you got that one right. Now let's work out the angle between vector A and the y-axis. See if you can give it a go and press pause if you need. Well done. So let's see how you got on. Well, because we're looking at the angle made between the vector and the y-axis, that means we're using this formula. We already know the magnitude of A is 3 root 5. So now let's identify what we mean by y. Well, it's the j component, so that means it would be 5 over the 3 root 5. To work out the angle made between the vector and the y-axis, let's cos to the minus 1, giving me a final answer of 41.8 degrees to 3 significant figures. So that means the angle made between the vector A and the positive y-axis is 41.8. Well done if you got that one right. Now let's work out the angle made between vector A and the z-axis. See if you can give this a go and press pause if you need. Well done. So hopefully you've identified to work out the angle made between A and the z-axis, we're using this formula. We already know the magnitude of A as 3 root 5. So let's substitute what we mean by z. Well, z is given as the k component. So that means we're substituting in minus 4. So that means we have cos theta equals minus 4 over 3 root 5. Working out theta, we cos the minus 1 of the minus 4 over 3 root 5, giving me a final answer of 127 degrees to 3 significant figures. So this means the angle made between the vector A and the positive z-axis is 127 degrees. Well done if you got that one right. Now let's move on to another question. Here the question wants us to find the angle made between the vector 3, 6 and minus 2 and the positive y-axis, and we're asked to write our answer to 3 significant figures. See if you can give it a go and press pause if you need. Well done. So let's see how you got on. Hopefully you spotted it's given it in column form, but it's exactly the same, just be aware of your vector notation. So we know we're working out the angle between the vector and the y-axis, so we're using this formula. Let's substitute what we know. Well, we know the y is 6, or the j component is 6, over the square root of 3 squared add 6 squared add minus 2 all squared, as this is the magnitude of our vector. Working this out, it's our cos theta is equal to 6 over 7. So to work out the angle made between the vector and the y-axis, we cos the minus 1 of that 6 over 7 to give me the angle to be 31.0 degrees to 3 significant figures. Well done if you got that one right. Now let's have a look at our last question. Here the question wants us to find the acute angle between the vector A, which is given as minus 4i plus 12j minus 6k, and the xy plane. This is a great question. See if you can give it a go and press pause if you need. Well done. So let's have a look at what it means by this xy plane. Well, for the xy plane, we have to write a vector, and that vector must not have a z component because it must only contain the x and y components. So that means our vector would be minus 4i plus 12j, which would represent the xy plane. I'm just going to briefly show you with a quick sketch. So here you can see I've roughly drawn the vector minus 4i plus 12j minus 6k. And I've roughly drawn or highlighted that xy plane. So this is our vector to represent the xy plane. And we're forming an angle made between that xy plane and our vector. Notice how there is no z component. So to work out the angle made between the xy plane and our vector, we have to use a vector to represent that xy plane. And that would be minus 4i plus 12j. And I'm going to call that vector b. So to work out the angle made between xy plane and our vector, it would be cos theta equals the magnitude of b, which is our vector to represent the xy plane, over the magnitude of our vector. So let's substitute what we know. Well, we know the magnitude of b would be minus 4 all squared add 12 all squared, and then square root, over the magnitude of a would be minus 4 all squared add 12 all squared add minus 6 all squared. Simplifying this would give us root 40 over root 45, which simplifies to 2 root 10 over 3 root 5. So to work out the angle, we simply cos to the minus 1, thus giving us the angle made between our vector and the xy plane to be 25.4 degrees to 3 significant figures. A huge well done if you got that one right. So in summary, it's important to know the vector notation given for 3D vectors, as well as how to work out the distance between 2 points. You can see how our formulas were made to work out the angle made between a vector and a positive axis.
If you liked this video, please give us a thumbs up. Leave your comments down below and subscribe to this channel so you'll be the first to know when we release our next video.